Welcome everyone to today, February 4th, our ETM Distinguished Speaker Series event, and seminar speaker for today is Dr. Nasir Sheik. He's Associate Professor and PhD Program Director in the Department of Technology Management at the University of Bridgeport. He was a founding tenure-track faculty member in the Department of Technology and Society in the College of Engineering and Applied Sciences at the State University of New York in Korea from 2013 to 2017. And he teaches courses on entrepreneurship and technology ventures, leadership, strategy, decision-making, computer networking, and much more. His research interests include technological innovation, commercialization, technology assessment, decision modeling, agent-based modeling and simulation and analytics, and he has over 30 publications. With over 35 years of industry experience building global information and communications technologies as an executive, he's served in business leadership roles at Atlas Telecom, Ushacom, CenterSpan Communications, and HCD Systems. Prior to that, he has had technology management and operational roles at AT&T Labs, Nortel, Philips Electronics, and Schlumberger. He's engaged in management consulting on next generation renewable technology, energy, and healthcare technologies. He has a PhD from the ETM department in technology management. So he's an alumnus from the ETM PSU department here, as well as having a degree in electrical engineering from King Fahd University of Petroleum and Minerals in Saudi Arabia, and a BS from Middle East Technical University in Turkey. So please join me in welcoming Dr. Nasir Sheik. Thank you.
Thank you, Dr. Anderson. I'm very excited to be here, especially because I'm an alumnus. And I do recall on June 16, 2013, I graduated with my PhD, and on June 17th, the next day, I took a flight to South Korea to start my first job as a full-time faculty member of SUNY Korea in Songdo, South Korea. So that's how it all started. And I've been, of course, looking into strategic decision-making, not only from the point of view of a scholar and a scientist, but also throughout my career. And I wish I had known about these things earlier on. It would have really helped me. Because when we're making these strategic decisions, there's really very little to help us out there in the industry or out there in the field. So these kinds of approaches are really helpful. And the good news is that they are getting to be more and more common. And I'll talk more about what the different perspectives are. And I guess you'll begin to see my bias on these perspectives as well. So this colloquial is about strategic decision-making, but from two different perspectives. One is the perspective of experiential knowledge, and the other, the more famous one, is historical data. Historical data means big data, data science, getting all the data so we can make decisions based on facts and evidence, etc. I normally don't go through reading an abstract, but in this case, I like to read a few sentences because I think it tells us a story which is not common. And that is that operations research has traditionally been used at different levels of applied mathematics and data analysis for strategic decision-making. And it's been very successful, and scholars have even won Nobel Prizes for the discovery, such as with game theory. And with the advent of big data, this may be leveraged even more. However, this approach relies on variables and calculus for the results, and the number of variables tend to be limited. So what we're trying to say here is that even though great scientists and scholars have won Nobel Prizes in this area, one of the drawbacks of just using data has been that we are limited by the number of variables that we can evaluate, assess, and play with. But there's another approach which is based on decision modeling, and using expert judgments, which is not formulaic. And I want to compare and contrast these two and give an opinion. So as you can guess, the motivation, I'll talk a little bit more about the motivation for this seminar and describe some definitions. What is strategic decision-making? What is experiential knowledge? And what is historical data? Then I'll give a short overview of surveys of CEOs. This is not the latest survey, but it still holds today. And then go further into historical data and experiential knowledge and a conclusion from there. So this is not a rigorous research topic, but it's based on a thematic approach, which I hope that you will appreciate. So what's the motivation for this seminar? Well, the motivation is that research decision modeling is based on expert judgments. It's a form of Delphi method, and it's a very uncommon area. It's not uncommon in the ETM department, but it is uncommon worldwide, and I wish it wasn't. And this is part of operations research. So what is operations research? Well, essentially, it's three different approaches to strategic decision-making. One is called decision modeling, which I hope some of us are familiar with, and is based on the consensus of expert judgments, meaning that we get the opinions of experts and they derive some assessments based on that. The other is game theory. Now, game theory is based on strategies of conflict and dissent and outcomes. And as you know, that's also well known. And the last, the new one is decision science, which is based on data and algorithms. And today we are always highlighting the fact that now we can get access to so much data and we can make better decisions. And then we've got AI, and with algorithms, we can do wonderful things. So those are three main areas of operations research, but really it was designed for strategic decision making. And my own approach has been that I want to do joint research with both, with the data and using decision modeling. And that's what I, in the future, I'd like to do as well. So what is this strategic decision making? Well, it implies, our strategic implies that decisions impact the future. So it's not about today, it's about the future. And it should include the whole environment of operations. Hence, multiple perspectives should be considered, not just an economic perspective or a technical perspective, but also social, political, etc. And it implies that outcomes may be realized in the long term, even if decisions are made in the short term. So that's where the difficult part comes in. You have to make a decision today, but the impact may last years, if not decades. And how are these decisions made today? Well, in practice, we have, for example, and you may smile at this, but in practice, many times a decision by loudest voice, meaning the person with the highest authority makes a decision, or the recognized expert. Say, oh, well, we'll get this consultant, or he's an expert, he's done this for 25 years, or she's done this, and she will show us the path. Or it's just someone who raises their hand and says, I'll do it. And that's a risk taker. And these are the top three ways many times you make decisions at the top level. There's another way, which is done, which is the technical term is called boxat, or bunch of guys and gals sitting around a table. That's another way, a very common way, right? Sit down at a table once a year or twice a year, and everybody joins in, everybody's an expert or a decision maker, and make decisions that way. Of course, the new way is with data science and dashboards and analytics, and that helps us, and many, many more. But this is how it's done in practice today, believe it or not. So what is experiential knowledge? Experiential knowledge is human knowledge based on long-term experience. It gives us expert judgments because of our experiential knowledge. Research is broadly related to what is called the Delphi method. The Delphi method essentially uses experts, and it's an iterative process where experts are polled about different decisions or aspects about the future. They give their opinion. Everybody and all the experts are then relate those opinions, and then another round goes into the iterative process until everybody has a consensus on how that should be about the future. And of course, when we are dealing with experts, we're also dealing with humans. It may include explicit, tacit, and genetic experiences. What that simply means, it's all of us. For human beings, we have emotional aspects of us, we have cultural, we have experiences, maybe different experiences based on our type of work that we're doing or where we live. And it may include intuition. Again, intuition, I believe, is really experiential knowledge and maybe genetic knowledge, but it hasn't been codified. So we don't know exactly how the dots connect, but we know because of experiences that it generally helps us. So that's intuition. Explicit relationship between cause and effect is not codified. This is what as I explained, this is part of the reason why experiential knowledge is important, but we can't really put our finger on it. How did we get there? Was it like, did we find this truth last year? Or did this truth accumulate over a decade, maybe 2 decades? Explicit relationship of inductive and deductive logic are not codified either. So somehow we came to a conclusion, whether it was implied or it was deduced, and maybe it was through many different experiences. We said, and of course, typically the way it works is we first find out what we don't like, and then we find out what we like and what works, and so on. And it's not based on algorithms or formula. So it's not a formulaic approach, but it's a whole person, whole experiential knowledge approach. What is historical data? Historical data is a construction of results or patterns from data over time. So we can either see, okay, this is the trend because of the data we got, or this is the cluster analysis, if we do a statistical analysis, or this is a regression curve based on some predictive scatter plots that we have, or just lots and lots of data that's been collected over time. Again, it's all historical data. It's not, but we are trying to do strategic decision making, which is about the future. So it has to be predictive in some way. And the tools we use are data science, machine learning, analytics, et cetera, et cetera. Some of the things that are useful in predicting the future are probability density functions, which are based on histograms. Now, histograms are again related to history, meaning that we get some probabilities developed because we tossed the coin so many times before. And let's say, a certain number of times, and we said, okay, 50%, the probability density tells us there's 50% heads and 50% tails. And of course, with more complex scenarios, we build a probability density curve, and that helps us define what will be in the future, what's the highest likelihood of something happening in the future based on the past. And then, of course, we use combinational properties that, given that it rained yesterday and it rained on the same day for the last 10 years, we can say that based on that condition, it's likely to rain again next year as well. And then utility curves are another form, especially used by economists, but it's again based on past outcomes. So we say that the utility of a certain action or a certain product, it has, let's say, could we convert that dollar value, if it's a $100 product, we convert utility of 0.6, meaning it has a usefulness of about 0.6 or 60%. And that's a common theme used by economists. And of course, decision scientists as well. And typically, all of this ends up with formulas and algorithms that are derived from empirical data. And what I mean by empirical data is these are experiments done in the past that will help us predict the future. So this is a little different than experiential knowledge, where we don't have formulas and algorithms. But in the case of data, we have this luxury of this great new world where we can just apply a lot of compute power and get results. So these are the two metaphors for decision making. either using experiential knowledge or using historical data. Of course, we can use both. But in reality, what happens in the real world is that we tend to have biases towards historical data because that is the bigger, more famous approach to things. So let's talk a little about how executives make strategic decisions. Well, surveys have shown that executives tend to rely on their judgment for decision. And if you look at it, the survey, this is by industry, across the board, most executives rely on human judgment as a final approach to making decisions. Of course, they rely on data and they would like more of it, but their final decisions are not based just on the data itself. And surveys have been done by country, and against the same result, executives and CEOs tend to make decisions based on human judgment, by decision type also, whether the business is shrinking or they're expanding or there's restructuring, and if there are changes to business operations, all of this, by and large, CEOs and leaders tend to make decisions based on their own judgment, experiential knowledge, and maybe the experiential knowledge and judgment of their major consultants and advisors. So now, going forward, let's talk a little bit about the popular metaphor, as I mentioned, is historical data. We just love data. And another name for that is decision making by numbers. So what's great about this? Well, first of all, we can apply random variables and probabilities everywhere to solve problems using actually techniques like probability density functions and equivalent, and saying, okay, if the probability of an event or a certain outcome, like so much profit has been, it falls somewhere in the probability density curve, we can say, okay, well, the probability is so much, so the chances are pretty good or pretty bad that will make a profit. Problems involving determining dependent variables that are related by composite probabilities that are independent or explanatory variables. What this means is we can solve problems that where we can relate independent variables to a dependent variable. What that means is that if we have certain factors we know that are independent but are important, like let's say economic feasibility type of factors and technical performance type of factors, like the price of a unit and performance, that it has so much CPU power, we can relate that to, let's say, making a new chip, and that's the dependent variable of having certain overall processing power. Okay, so we have, in fact, a lot of the research is geared towards this, and it's typically inductive logic, which means we correlate independent variables to dependent variables. And we're really looking for the dependent variables, but we have only independent variables to work with. And then lastly, we have patterns or relationships described by equations or formulas. So that's why this is so great, is because we have data, we can get the variables, and we have equations and formulas, and they help us decide about the future, and we can extrapolate the past to the present. And I hope and I think you're all familiar with these concepts. So what can we do with that? Well, there are well-known S-curves, for example, like the ones you see with the radio and television and cable TV, pay cable, VCR, CD players, and so on and so forth. We know that technology adoption follows an S-curve, and just by plotting out different things, for example, we can use patent data and see how do the patents progress, and we can get S-curves, and we can predict out, because we know the formula for the S-curve, like the famous Fisher-Price curve. The Fisher-Price curve helps understand how technology will be exchanged for new technology, and it tends to follow an S-curve type pattern. And it has certain inflection points, and the formula is well known, so we can plug in data and apply the curve and predict how the technology will fare in the future. what this growth will be when it will emerge, or it will be the high growth, and when it may mature out. Of course, then there's the famous multiple players and payoff matrix in game theory. So if there's strategy A and there's strategy B and a player 1 and player 2, and for example, if strategy B is player 1 makes $100 and player 2 makes $0, that's the winning strategy, then we say that is the payoff matrix that will help us win, or some other combination. And this has been well established. And like I said, game theory is so popular, so well known that people, not just one, but multiple players have won Nobel Prizes like Thomas Schelling, and The Beautiful Mind, made famous by the movie The Beautiful Mind as well. Professor. Okay, then there's the utility curves I mentioned earlier. Well, utility curves help us understand utility versus the dollar values. And as we plot them based on historical evidence, they also help us understand the risk aspect of the decision makers. Well, if the utility curves tends to be concave, then we know that the decision maker is risk averse. It tends to be a straight line, it's risk neutral, and otherwise it's risk seeking kind of decision maker. So what are the limitations? These are great tools and great approaches to making decisions about the future, and well established and well recognized. So the limitations are that they're limited in terms of variables we can use, typically 1 to 5, not more than 6. Why? Because the formulas get so exotic that it's difficult to translate them to the real world. So it's just a mathematical exercise. The other problem is that you can only have a limited number of players and strategies. So these are what we call decision elements. If you have too many, again, the same problem happens. It gets too complicated, we can't really make it practical. And then another aspect is we are relying on probabilities based on past experiments. Well, COVID, for example, 19 has shown us that past experiments don't really tell us about the future. We don't really know suddenly how the uncertainty will be affected in the future based on our past experiences. Especially in the last 100 years, we haven't had a pandemic. So the experts have all sort of are not with us anymore, more or less. Many assumptions are made to simplify the problem. And that's another big one. Because we can only apply formulas and algorithms in limited fashion to limited number of variables, then we have to make assumptions. And we forget that we have made those assumptions. So as new assumptions arise, we don't incorporate them in a timely fashion. And so there's a limitation there. If big data is used, then data needs to be scrubbed to ensure that only good data is used. Well, we all know that at least 30% of the time is used up in cleaning up or scrubbing the data to be used for big data analysis. And the scrubbing or the corrections have to be made because the data may be corrupted, or it may be duplicate data or missing data. And that's not very helpful in going forward with the big data analysis. Another drawback is that many times only 1 or 2 dimensions are considered when we are looking at these historical data and using even big data. And they tend to be typically around time because we like to predict for the future. And the problems in real world are actually more complex than that. They are multidimensional. So example is that if we look at the probability density functions and we apply and we said, okay, we've been using this for the last 20 years, we can use it again for the future, and it may not be valid for the new context because there's no thinking beyond that. And that's where I guess expert judgment sometimes comes in, where there's experiential knowledge, but there's multifaceted approaches to things. So anyway, but I'm not saying that these are not useful. They are useful, and they're definitely applicable in a lot of the cases using historical data. So let's now talk about the lesser known metaphor, the experiential knowledge metaphor. And it's also sometimes called the decision making by enigmatic art. So enigma means it's a mystery. So we don't know how the formulas have been connecting all the different parts and pieces and variables together. So if we look at the challenge of decision making using experiential knowledge, so let's just try to understand that. Why is that not so popular? Well, first of all, it's difficult to understand. How was this decision made? Because it's based on lots of experiences in the past. And it may include varying biases. Every human being, even though they have experiences, they may have different biases. The biases may be cultural, may be based on their own personal journey through their career or other professionally oriented experiences. It's difficult to capture in a rational model these kinds of approaches. And it's difficult to get insight into granular decision elements. So how much can we say that it's related to variable X or Y or Z? And what's the formula that connects them? And they may be preempted by psychological manipulations like things that have just happened in the past, or there's something called the amygdala hijack. Amygdala is that part of the brain which controls our emotions. And the psychologists know about the amygdala hijack is sometimes that part just takes over and we react to things that we can't rationalize over. So how do we go about building rational decision models? What we have to do is look at the bigger picture. The bigger picture is that the human beings, to make a decision, first we have to have our attention toward. So we have to understand that, yeah, this is a problem we're going to address. Then there's the perception, then there's the intelligence applied to it. And then there's built-in biases which sort of creep in and may be good or bad. Not necessarily, biases are not necessarily bad. And then we apply expert judgments. And using all these approaches, we can end up with a rational decision model. And I'll explain how that we can do that despite all these challenges that we have. So another definition is with respect to experiential knowledge is expert judgments. Expert judgments can be used to represent a class of decision-making relying on experiential knowledge. Now, what is an expert? Typically, studies have shown that someone with about 10 years experience is an expert because they have lived and they live that life for 10 years and have gone through many different experiences. So they have a reasonable expertise in that area. And the 10 years really implies, let's see, 20,000 hours, but we don't assume that someone is going to spend 100% of their time, so that therefore it's about 10,000 hours, which is about 10 years. And now if the judgments can be quantified, if we can somehow say that, this experiential knowledge, we don't necessarily have to know every detail or formula how we got there, but we can quantify that judgment, meaning we can say this variable is important or not to make our decision. And we can use statistical analysis to do that, then the judgments become more robust. So I guess the key is trying to quantify this challenge that we have, or what is a experiential knowledge or pieces of it, or the elements of it. And if we can make it, we can quantify it, then it's helpful. Then we can work with the numbers. Then we can also check the judgment for consensus among multiple experts. And that's another important aspect, is that one expert is not enough, because one expert may have biases built in, as we talked about earlier. So we need a consensus. And typically they say about 10 is a good number. Studies have shown that. Having too many experts doesn't help, and having too few may give us erroneous results. So experiential knowledge is judgment quantification. So how can we apply that? Well, if we can say expert judgment based on decision modeling captures several things. Judgment of multiple decision makers, if you can do that. Judgment of multiple experts, and multiple dimensions. So if we can have it in this 3D format, especially if they're not just one decision maker, there's multiple decision makers or multiple stakeholders involved. And if we can have multiple experts for each type of dimension or perspective, then we can have a holistic and a robust decision around a complex problem. So, and if you can quantify these judgments based on the above, then this becomes really very useful experiential knowledge. If we check the judgments for inconsistencies and disagreements, now this is very important because as human beings, we can be inconsistent. So if there are statistical methods to check that. So we can check for human inconsistency, and we can also statistically check for disagreement amongst experts. So if we can remove those two aspects or reduce them, if we can't really remove them 100%, but we can reduce them such that there's a 90% consistency within the expert, him or herself, or there's 90% agreement between the experts, then we can say this is pretty reasonable and we can go forward with a consensus approach. And what we do is we can apply a weighted average approach to the judgments. What this simply means is this, that in effect, even though this is we can make a decision model based on experiential knowledge, but if you can apply and we quantify this, and then we take the judgment of all the experts and we apply a weighted average approach. And we know weighted averages have been used everywhere for at least a few hundred years. And they tend to tell us, okay, in terms of judgments, it's a good consensus approach. So that's the weighted average. And then we can rank order the alternatives under consideration. So we can say if we have 5 alternatives with the, let's say 100 points for the best one and the worst one comes out to be about 50, we can sort of rank order the 5, say it goes from 100 to 90, and we can do a ratio scale comparison between them and say which one is better or worse. And one other nice thing about making such models is that once the model is made, we can apply sensitivity analysis, and we can use the analysis to determine the impact of changing decision elements, where we can have what if scenario. We can say what happens if we said right now that the economic perspective is 30% of the decision. That means it's reasonably important, but it's changed now. The political perspective has now become 30% and the economic perspective is 20%. How will the decision change? And once we have the model and we've quantified it, and that's the nice thing about quantification is we can then work with the numbers. We can change them, we can shift them, we can play what if scenarios, and we will get results that are based on quantifiable outcomes. But these are not formulas. These are essentially changing judgments into quantifiable entities. So then we can then look at numbers, and numbers are always easier to work with. Okay. And so why is this important? Well, I talked earlier about algorithms and historical data. Historical data and algorithms tend to be on the analytical complexity side. They tend to handle things like you see on the lower side is the x-axis, which is analytical complexity, is things like uncertainty. Well, with probabilities, we can address some of those. Dynamic situations, things may change, and we can say, okay, based on certain conditions, probabilities may have changed. And we can apply interrelated variables. So the dependent variables rely on these 5 independent variables, and we can apply certain rules to that. And then we can have certain number of players with competing perspectives in the analytic complexity side. So that helps, but that really goes on the x-axis scale, where we can go from very simple analysis to more complex one. But when we come to organizational complexity, when we have multiple stakeholders, then we can have other situations where we have parties in conflict, and then individual and organizational differences. For example, values, desires, and motivations may be different, and of course, group dynamics. So if you look at both types of complexities, then the decision making becomes even more complex, and complex decision may be addressed using these type of models. That means the models that use experiential knowledge, because it requires processing, but at the same time, it has to be rigorous, and that's where the quantification aspect comes in. Now, on the other side, which is the low side, which is low organizational complexity and low analytical complexity, we can apply heuristics. Heuristics is essentially rules of thumb we can apply because we know about human behavior and we know about certain actions. For example, studies have shown that as individuals get more education, become more analytical, they also become more pessimistic. So that's a heuristic we can apply. And if they're and the opposite also is true, but the opposite optimistic people are less analytical. Now we can argue and debate on this, but these studies have shown that this is generally a heuristic that can be applied. And it's very simple. We don't need to build models for that. But we have a situation, let's say, that there's a dam to be built, and there's a social perspective, and then there's the cost, the economic perspective, there's the political perspective, where the funding will come from, how many society, and then the social perspective will come into play, and the environmental perspective, and so on and so forth. Then it's a far more complex problem. And it's not enough to do just a traditional cost-benefit analysis. It has to be much more rigorous. So the kind of models that we use actually that can be used with this experiential knowledge, all have the same kind of framework. There's an overall objective. There are the criteria. The criteria can be the big buckets, which we call dimensions, and it could be the criteria which fall into these big buckets, which we call criteria. But essentially, its overall objective is the criteria, and then lastly, you have to have alternatives. So for a model to be worked at, it must have those three parts: the overall objective, the criteria, and the alternatives. Yeah, we can interject more functionality into it, but we must have at least the three major components. And this can be used in many, many different areas, and it have been, especially for large capital projects. The impact may last for 20, 30 years, and the military uses it, large construction projects use such approaches, but it's not common overall. And we can use for resource allocation, business policies, and so on. In fact, as an example for public policy, in the 90s, the Finnish government needed to decide on what kind of power source they would have for the country. And they were looking at the nuclear and hydraulic systems, and so hydroelectric power and so on. And they used a sort of a similar model to decide that they would go with nuclear energy. So what is HDM modeling? Well, HDM is a form of the model I just showed you, and it stands for hierarchical decision modeling. It's something that's been developed at Portland State University, Department of Engineering and Technology Management, and it's used to address complex problems. So the nice thing is, so there are many nice things about it, but one is that it does address complex problems, but also it's a very perceptual model. As you can see, when you saw the earlier framework, that we can immediately see what the pieces are and how they link up. And it can be used to obtain a comparative assessment of competing perspectives and criteria for a particular worldview. And the criteria may be quantitative and qualitative. So we can have competing criteria, and we can compare apples and oranges, and we can then come up with an assessment model for what we're doing. And the only caveat is that if you build a model, it has to be for a particular application or worldview. We can't just have that model and say, okay, we developed it, let's say, for the case for Finland, and we're going to take the same model and apply it for US. It doesn't work like that. We have to reevaluate the model make sure that it applies for the different worldview as well. But I think it's a great starting point. So what are the steps in building the model? Well, the steps are state the objective, define the criteria, select the alternative. So this is the first three parts are just essential. And then the next steps uses experiential knowledge, expert judgment. We obtain the relative importance of the criteria based on expert judgments and determine the relative contribution of each criterion to the objective. So we can say that 2% of the decision for deciding on what is the next generation of electric power will be used for Finland, 2% came from, let's say, the social aspect, or I should say 2%, of one of the criteria within the social aspect, at how it will serve all the communities with sufficient power for let's say 50 years. And that is really a big plus. And then we can compare the alternatives with respect to the lowest level criteria, meaning that the steps are, for the simplest model is that we get the criteria and sub-criteria, and then we take the alternatives and compare them step by step with the lowest level. And why do we only compare it with respect to the lowest level is because by this time the model in the lowest level embeds in it all the other levels, higher levels of the model. I'll give an example so this will become clear. So the generic model would look something like this. We have the overall objective, we have the perspectives or the big bucket criteria, and then the criteria, the sub-criteria, which we call criteria, and the alternatives. And that's why it's easy, because we can see the model as a one-pager, if you will. So here's a simple example. And this was actually taken some years ago when stem cell research was being debated. And we have a decision model to understand the criteria and the alternatives and assess them. So there are three major perspectives here for stem cell research: opportunities, costs, and risks. And in this particular case, we just do a sort of let's say we're doing a back of the napkin approach, and we say 30% of the decision comes from opportunities, 30% from costs, and 40% of the decision is from risks involved. And what are the opportunities? Well, the opportunities are for medical advancement as well as social aspect of this. So social benefit. And under medical advancement, there's treatments and economic profits. And costs, we have funding and commercialization as our costs. And under risks, we have the medical development, and we also have social risks. And under social risks, there's moral issues and religious issues. And as you know, this was in 1990s, this was really critical because America wanted to stop stem cell research. So the consideration was that three types of funding approaches we could have. The objective was how to get funded for this: adult stem cells research, embryonic stem cell research, or no funding at all. So those are the three alternatives: only adult stem cell, embryonic, or no funding. Something happened, sorry. So you can see that if we just multiply out, we can get results quite easily from a simple model like this. Of course, we can have more complex models, such as assessment of photovoltaic technologies using 5 perspectives: STEEP, social, technical, economic, environmental, and political. And as the results came out, we realized that all the 5 perspectives were not equally important, but were material, meaning we could not ignore any of them because of whatever reason. And typically in the past, only the economic, feasibility, and technical performance perspectives were considered because they were the most important but social, environmental, and political were ignored. Well, in today's world, they cannot be ignored. And for things like job creation and negative publicity is very high on the social side. On the political side, a national priority, a local sourcing, and regulatory risk are also very key. So this is besides the technical and the economic perspectives. And we did a study and found out that there were quite a few important elements for the decisions and which you call criteria to be looked at, and experts help decide the weight or the importance of each one of these decision elements. So for example, in the technical side, module energy efficiency, typically we think that's the only thing that's important is how efficient is this this photovoltaic module. Let's say it's a 20% efficiency, that's really good, but 22 is better. That's not enough. You can see that there were about 40 elements here. And if they be considering all the perspectives, it's not enough to just consider the efficiency aspect. And when we look at a little bit more complicated problems, where the things are more interrelated, this was for identifying new target markets for a new personal healthcare device. And essentially here, the problem was that an asthma personal care device for asthma detection was developed, but the firm did not want to pursue the medical side of the device. They wanted to go for consumer products, and they were trying to assess intermediate markets. And the perspectives they were looking at was that this was a firm which had a global presence, and they wanted to understand the market objectives, the financial perspectives, the product objectives, and also how did it align with the corporate objectives. And so you can see there were many factors, many criteria, many perspectives, many criteria, many sub-criteria, and the alternatives were, for example, home care market and the fitness lifestyle market, wellness market, and so on, because basically this device helped collect breathing data and patterns, and it initially could detect asthma attacks way before they happened, but it could be used for many other purposes. And such a model helped decide which is the intermediate market to go after. Okay, and of course, this is a sort of an eye chart here, but when looking at it in large scale, it's very easy to see all the factors and how they relate, or all the criteria and how they relate to the decision, and what the alternatives look like. And this was done in 2016, actually, in about 10 minutes. And this is what I call back of the napkin decision model. So one doesn't have to spend, months and months of research and get all the experts. But if one has enough basic knowledge, we can try to make some models that help us make some decisions. For example, this was just before the elections, and it was the assessment of the next US president. So at that time, I remember this is done very quickly, back of the napkin, but still, I look at it today and it seems, wow, it seemed to be relevant at that time. So what are the perspectives of the dimensions? There's the foreign relations, there's the economy, jobs, popular vote, electoral college, special interests, and there's the lobby groups, and being presidential. At that time, being presidential was getting to be important. Not so much somehow. But anyway, what were the foreign relations? China, military engagements, free trade, the economy, and so on. And you can see, for example, free trade was both in foreign relations as well as in the economy. There was a connection there. And then under special interest, there was Wall Street Corporation, there were minorities, there was the white males. That was an issue even then. And the alternatives were Bernie Sanders, the Democrats, the Republicans, and Trump. So even though we can spend more extensive, rigorous research, but should not stop us from making models like this, which I just call the back of the napkin decision models, It's like the back of the napkin business plans. In fact, in all the research that I've done for myself and with my students, I always encourage to, even before you start all the rigorous process, is to do something like this for yourself. It's really an eye-opener. And it's amazingly simpler, much simpler than we think. It's like, mind mapping. Once you start doing it, it's amazingly simple because it's exactly how our mind works. And also this is very visual. It's a perceptual model. So we can see which blocks are missing. And we just have to listen to the news maybe sometimes and we can get some results, or read a few articles and we can add elements just by reading articles rather than having a treatise on each section. So those are the types of models that can be developed, and you can see they can handle very complex situations. But what are the limitations? So the limitations, for example, to start with, we need to get IRB approval. The IRB is the Institutional Review Board, and almost all the universities in the United States require it if we are going to have any human interaction. It was originally designed to prevent invasive actions for medical reasons, and to protect society and citizens, because people would not people, but university would do experiments on human beings without telling them what was to be done. However, it's become sort of standard amongst all the universities, and since one has to deal with experts to get their opinion, even to get their opinion with a survey, an IRB's approval is required. And that's extra paperwork and extra procedures to follow before one can embark on this. So that is a limitation. Whereas with formulas and other things, we don't necessarily need to have an IRB approval. In fact, typically for these kind of studies, you don't need approval per se for the process. You can get the approval for an exemption. So it makes it much simpler. Then the second difficulty is getting access to decision makers and experts, and getting them to agree to do what we call a research instrument to completion, which is essentially a survey. And the reason we don't call it a survey is because it's not taking a sample of a population. It's actually the population of experts, of 10 experts in each dimension of perspectives. So that takes some work. And sometimes what happens is experts agree, but since it's a consensus process, they don't want to agree with everybody else, so they drop out. So then we have to have more experts than are needed. And it takes time. So it takes months to build a model. It doesn't actually take as much time to build the initial model and the framework, but to have it validated by the experts and then to go through several steps with the experts to get elicit their judgment, expert judgments. It takes time. And of course, before we collect the experts or elicit expert judgments, you have to make sure that the experts are well-rounded, meaning that they don't come from all the same place, so we avoid groupthink and things like cognitive dissonance, meaning that people who change their mind a lot over things. Okay, so that takes time. And the modeling in the end does represent rational decision making, and it's that little circle within all the big circles. Eventually you get to this point that we thought of. So what's the answer? The answer is, well, you can't say, it depends on the problem. And there's no panacea. If we use experiential knowledge, we have to make sure that the judgment is good. So we have to apply statistical analysis on consistency and on consensus. That it's consistency within the expert own opinions, and that the pool of experts for that particular dimension or perspective agree to a certain level. And for historical data is to validate that. That's pretty critical. And as you know, many mistakes have been made because data was not validated appropriately. It may be because of the assumptions used, or also because some of the data, the sources may have not been valid. So, but for complex and multidimensional problems that involve shared decision-making and have significant impact, it would be worthwhile to use decision modeling and expert judgments. And it is better than oversimplification, multitude of assumptions, and formulaic approach with data. So what does this all mean in the long run, or in the long term? Or as human beings, as we are now worried about artificial intelligence taking over and so on. So I drew this 2x2 matrix. I actually am a great fan of 2x2 matrices because they represent a dialectic, representing two truths, if you will. And just like I'm a fan of decision modeling, I'm also a fan of this because these are good strategic decision-making tools. So on the x-axis, we have artificial intelligence, and on the y-axis, we have human intelligence. I know we don't use this term much, the human intelligence term. We only talk about artificial intelligence. But if you look at it, human intelligence can work with complex patterns and scenarios and other things humans are good at and better than machines. And even if we take computer visions, robots can only do so much with just computer vision, whereas human beings can do much more just by vision, for vision alone. Artificial intelligence. Well, artificial intelligence gives us fast computation and deep pattern recognition. And we know this. So if we take experiential knowledge, that actually leads us to strong human intelligence. If we take historical data, it leads us to strong artificial intelligence. And if we can look at the 2x2 matrix here, and we see the high, then if we can combine the two, that's probably the best. And that's my take on the matter. And there we have it. I hope this was informative and helpful. And I'm open to questions.
Great, thank you very much. If people have questions, please feel free to type them in the chat, or you can go ahead and raise your hand and we'll call on people. So I'll start with a question. Have you used analytical decision-making in all the complex decisions we've all been wrestling with in these COVID times? And if so, how? For example, issues of vaccination or otherwise, or working from home versus working in the office?
I wish I had. I haven't had the chance to, but I would like to. We've used a slightly different analytical approach for a different problem. It was why there were not enough African Americans in innovation. And that was a PhD research dissertation, and it was using simulation. But it's a kind of analytics, except we generate the data based on the action and interaction of the players in such a system, if you will. So system would be the government, entrepreneurs, the non-African American entrepreneurs, and the African American entrepreneurs, and universities, and so on. So those are the agents, and then we can generate data and apply some random stochastic processes that gives us some results which are not decision modeling as such, but they're simulations and computational modeling. So done to that level, we've done that. And we've done that also for industrial design application. So for example, one of the problems is when new products are introduced, the cycle from new product to industrial designers and back takes a long time, because it takes a long time to get feedback from the clients or the early customers and get them into the design cycle. So we applied this computational modeling approach. Again, it was somewhat analytical, And we got some efficiency improvements based on that. But the design cycles become much shorter. But I don't know if that directly answers your question, which needs work.
Yep. Okay.
Thank you for the question, though. I think it's an important one, but we haven't addressed it yet.
Okay. And Chip, you had a question.
Yeah. Oh, great. Yes, I did. Thank you. And if you can hear me, can we make models that can be matched to historical data over very long time frames, hundreds of years, thousands of years? It's my impression that the HDM is a one-shot, yes or no, one of
That's
five
right.
alternatives.
This kind of modeling would again come under the umbrella of computational modeling, which you could do. But again, I'm not familiar with all the different types of models, frankly. But in computational in agent-based modeling, you would have to define, let's say it's over 100 years. You'd have to define the players and their profile and characteristics in the sense of what did this player do? How did they impact other players? And what triggers them to what action? So we could take a pandemic model of 100 years ago, because we have a lot of data, hopefully we have a lot of data on that, and we could put that into the simulation model and then come up with some results. Because essentially, it's when we don't have formulas. This is not a formulaic approach. It's essentially it's more of a stochastic system approach, which is we have random variables and we keep running the simulation so many times, and eventually a pattern evolves. And we say, based on this pattern, and these are the triggers, and these are the interactions, these are the results. And that's all we can do. That's the best we can do. We cannot. But these, by the way, I just want to give a little plug for that. This is not, by the way, this is not hierarchical decision modeling. It's very different. The person who did this first time was Thomas Schelling in 1960s, late 60s, and he published first time in 1970. And Thomas Schelling went on to win the Nobel Prize for game theory, by the way, for something totally different. But he did it manually. He did the simulation manually. And they have shown that these kinds of simulations are very accurate. He did it and his model is called the segregation model. It's well known among economists. And basically, he said, what would happen if African Americans moved into a white neighborhood? And quite frankly, I was very sad to see that since that time, nobody had done any simulation modeling like that until I like to call my PhD student, PhD colleague, did his dissertation on African Americans on innovation. So, it was just ripe for a lot of investigation. This kind of computational modeling, because it's easier, is done more in the biological sciences and ecology. So they say plant growth and bacteria growth and so on, what they can see how it develops. But it's been very successful in the other sciences, not in the socio-technological disciplines that we have.
Great. That's a very comprehensive answer. Thank you.
Oh, thank you.
So Riyadh.
Yeah, good afternoon. My question is, on the second part of the decision-making process, so we spend time, we do the modeling, make the decision, and we start implementing it. Mm-hmm. Then data start coming back. Because they are strategic decisions, that means the strategy takes time to be implemented. And then as we're monitoring the implementation, we get data. And are there methods to measure the data and see if we are on the correct path to implementing the strategy, and how long it takes to analyze this data, random data from accurate data, to reflect on the strategy and the decision-making process, if we did the correct decision or not.
Okay, so I guess there's several parts to this question here. So first of all, yes, I agree with you that the decision is deterministic and it's a point in time based on the known factors or the known conditions at time. But we don't have to wait to see all the results. We can do a what if scenario. For example, we can say, what happens? We have a certain policy, let's say a certain regulation, and this is 10% of the total decision. What happens if this regulation suddenly becomes 20%? How will the decision change? Okay, so we can do what if scenario. Since we have the numbers, we don't have to take the same numbers that we had when we did the overall decision for this particular worldview for this time period. We can play what if scenarios. We can say, what happens if it changes, the policy changes, or we are going to a different social setup where the public perception becomes so critical, negative publicity becomes so critical that it changes the whole scenario, right? So then we can apply a gap analysis between that and where we are today. So we can do and also we can do something, the equivalent of game theory. Nash, the person of the beautiful mind, Nash's equilibrium is essentially saying that the player will not change their strategy regardless of the other player's strategies. That's the Nash's equilibrium. And we can apply the same concept and apply it to decision modeling. We can say, for example, the political perspective is the most important, the other perspectives don't matter. Let's say. That was the same thing that this player is, their strategy will not change regardless of the strategy of the others. And we can see what with the ranking of the alternatives this way. How will the decision change? By the way, I did this because I started to dwell into this and by chance discovered that this was actually strategic decision making had two branches. One was based on game theory. The other one was based on decision modeling. And nobody's heard of decision modeling and everybody loves game theory. So the thing was this, that decision modeling, we can apply the same principles. We just have to give them the same names as the game theory. Then we can say, okay, that's how it works. But anyway, long story short, you can do those kinds of things. Apply what if scenarios to see how far off we'll be if the conditions change. That means the decisions that means the alternatives will change or not change, but the ranking of the alternatives. Does that answer your question, Riyadh, or do you?
I think I know we're limited on time, but I think what you told me that we should do this what if scenario before the making decision to measure all the aspects. My question was, after we do this, we start implementing and monitoring, and we start moving, we launch with the execution of the strategy. And once we do that, there are a lot of costs and money and moving people and resources put into implementing the strategy. And error happens in the implementations. And I think my question is, how do we know if the strategy was correct or the implementation was having some troubles?
Okay. Again, this is a complex, a very complex question to answer. I would do it this way. Once a decision model has been made and sort of you rank, we can do some what if scenarios. You may be using this game theory approach, doing the extreme cases. Let's say that there are three perspectives. We take one at a time and say that is a dominant perspective. Others don't matter. So we have sort of the range, extreme range. And then I would apply strategic road mapping to it and get those details of high-level tasks and lower-level tasks to be implemented. And then monitor the tasks. It's not the end game, which is, you can certainly say, yeah, this is right or wrong. It's the individual tasks that have to be monitored.
Okay.
And that can only be done over a time period using a roadmap. It's like a project plan.
Okay.
And so those tasks, if you see if the tasks are off, or if they're not matching what the objectives were, right?
Okay.
And then even before the crisis happens, one can actually anticipate the issues. So it's not it's a different model, different analysis has to be done beyond the decision modeling for that answer. Does that make sense to you?
That makes sense. Thank you.
Thank you very much. This brings us kind of to the ending time as well. So thank you for an interesting and enjoyable presentation on decision modeling and decision making, something all of us have to do every single day. And some studies have said managers have to make hundreds of decisions every single day, from the small to the large. And so analysis and tools that can help us do it better are all the more important. So with that, please join me in thanking Dr. Nasir Sheik.
Thank you very much.